Tony here, local electrician for Mansfield and Ashfield. After have a look at a job today which I thought was ideal for my second ever video. There's quite a bit to do at the customer's property, but today we're concentrating on rewiring the garage. The customer's rang me, he's had a little bit of building work carried out. They've taken out the old system, he's turned it off in the house, isolated it, removed all the old system from the wall, so it's our job today to go and disconnect it and to rewire the garage. So that's going to be a couple of sockets, a couple of lights, and then probably another socket because he's having an electric garage door installed. Okay, so we're at the customer's property. As you can see behind me, there's a new door that's gone in, new lintel, etc., which is why they had to take all the electric accessories off the walls. So they're behind me on the table here. They've also done a bit of work on this window as well. So yeah, it were all down this side, so they've all had to come off. So we'll strip that lot out and we'll start putting some new stuff in. Right, so we've got the new fuse board mounted. That length of trunking behind me there, that drops down, that's an external socket, that's outside, just the other side of that window. New cables up and in. We've got a new light switch, two sockets where the workbench is going to be. They follow along. We've got one of the light fittings up, and that's ready to be terminated. It's all up and out of the way. Couldn't clip direct because the lintel's there, so we've gone through the joists, keep the cables up nice, neat and tidy and out of the way. The other light down the other end near the door, that's ready to rock and roll. There's another light switch there, that's ready to be terminated. And then we've got a twin socket there, that's going to power the garage door motor when the garage door's installed. And I think there's possibly a light on it, so they've asked for a twin up there just in case. If not, we can pop back and swap that over. Right, let's start second fixing. So some of the more eagle-eyed viewers out there will have noticed that when I second fixed the final light, I left the cover off. The reason for leaving the cover off is so that we can test it. So we always test from the fuse board. Them two cables there are the line conductor and the CPC, also known as live and earth to probably most of you guys at home. The technical term is CPC, circuit protective conductor, line conductor, which used to be the live or phase conductor. They keep changing their minds on it, but that's to the latest regulations. It's identified as a line conductor. So what we're going to test is the continuity of both of these cables. Obviously the earth or CPC for obvious reasons, to make sure it's got an earth that end, so that if there is a fault it finds its way back and trips it out. So we've connected them both together at that end of the light fitting, which is why I left it down. So this side we're going to connect the test meter to it and have a look, see what reading we get. Make a note of that reading, as we're going to need it for filling in the test certificate. So that's saying it's open circuit, so the connection on the light, does help if you turn the light switch on. Let's try that. There we go, 0.42, happy days. So I'm going to switch the other light switch to the other end to switch it off, switch it back on this end again because it's a two-way light switch, just to prove that that continuity all the way through. So if we turn that one off, that's the tester saying there's no continuity. That's beeping, which has told me it's got a steady reading of 0.41. So we'll take a note of that reading, and that's the R1, R2 complete for the lighting. Okay, so we've done a lighting circuit. Next up, it's the radial or the socket circuits. This not wired as a ring main. Most of the time in your houses you'll find a mixture of ring mains or radials. The old-fashioned ring main goes all the way around. Radials just come from the fuse box out to wherever it goes along the way, and then to one final point, so similar to the lighting circuit. Testing this the opposite way, I've got a plug adapter for the test kit, so we've connected the line conductor and the CPC together at the fuse box, and then if we make our way over here, we've got that plugged in, which comes down to the tester. So if we ask the tester to give us a reading, 0.15, although that might be reading backwards because I've got the camera facing the opposite way around, but that's R1, R2 on the sockets. Now we've proved that, done insulation resistance, which is basically making sure that there's no insulation faults or short circuits. That's R1, R2, so we've proved that we've got a good earth. So the next thing to do is to power up, and then we're going to do what's called an earth fault loop impedance, which adds on the R1, R2 out onto the grid to make sure that the earth goes back to the substation and then comes back down the line conductor. And it'll give us a complete loop from obviously live to earth, because they go back to the centre tappings on the substation. So we'll put this back together, we'll juice it up, and we'll do some live tests. Right, live testing then. So main switch is on, the socket circuit's on. I left the lights off for the moment because we've got to do some connections down the other end. But we've altered the configuration on the back of the tester, so it's plugged in. It's now on to mains reading. So if we ask it to perform a loop test, it's telling us we've got 244 volts there. We'll let it settle down. As soon as it's settled down, the little bar will stop flashing. There we go. Ask it to perform a test, and it gives us an earth fault loop reading of 0.72 ohms. So that's as ZS. Right, we're going to perform the same again on the lighting circuit. I'm going to fire that up. There we go. So first lights come on. Now I'm only going to test this in one position with a switch because I don't want to leave these dangling down too long. Obviously we're straight on to live connections there, so we don't want to be leaving them too long, but we've got no other real alternative while we perform this test. So same again. .88. Now the reason that the lighting, although the circuits are about the same length, the reason that the lighting circuit will be giving a higher reading is the cable is slightly thinner. So because it's a little bit thinner, slightly higher resistance, so that's exactly what we'd expect. Brilliant readings. Right, we'll just juice that off just in case it happens with them crocodile clips. Not that they should do because there's nobody else about, which is why it's safe for me to be doing it that way. We'll put the light back together, and then we're going to test the functionality of the RCD and make sure that that trips out. Right, the other light fittings back together. That's on and lit up, this one's on and lit up. There it is. Happy days. Right, I've plugged into this socket just here. I'm just going to do a quick test at both of them other sockets as well, but at the moment I'm just interested in the RCD to show you guys. So everything's switched on. We're going to set the tester to 30 milliamp automatic, so it's a 30 milliamp RCD. The idea being that the majority of RCDs in your houses for additional protection against electric shock is 30 milliamps. Anything more than that will stop your heart. The idea is that that should trip out before it stops your heart. It's not going to stop you getting a tingle, you'll get a slight tingle, but that should react in time to save your life. If you have not got them fitted, then I'd seriously consider upgrading your fuse boards. These things have been recommended to be installed since the 1990s, so yeah, if you've not got one of these with a little test button on it in your fuse box, then you certainly need one, protecting your sockets as a minimum. The wiring regulations state now that for all new installations the lighting has to be on and pretty much everything has to be on an RCD. So we're going to check this out and make sure that it tests out okay. So that's plugged in. It's on auto test, so it tests 4 times, 2 times at times 1, so 2 times at 30 milliamps, 2 times at ×5, and it tests at 180 degrees. So at 0, because alternating current is a waveform, it tests at 0 degrees once, 180 degrees once, 0 degrees once, and 180 degrees once. So if we hit test, it'll start running. This is just nulling out at half, so that's at 15 milliamps. 15 milliamps shouldn't trip it, that's just enough for a little bit of earth leakage. And at ×1, that's tripped in 34.4 milliseconds, so that's mega quick. Needs to trip within 40 milliseconds. It's tripped that time in 24. And ×5, 10. And ×5 at 180 degrees at 20. So yeah, that's pretty quick, and that's passed.